An inclined plane is more commonly known as a ramp. It is the only simple machine that does not move. Instead, objects are moved over it to raise them. It's easier to drag a heavy object up a ramp than to raise a heavy object straight up. The trade-off is that the object must be moved a much greater distance. The focus question for this activity is, how does the inclined plane reduce the effort needed to raise an object? In Activity 9, students are introduced to the fourth type of simple machine, the inclined plane. This activity will take about 30 minutes. The vocabulary introduced in this activity is inclined plane. The materials from the kit for each group of 4 will include a short board, a long board, a brick, a push-pull meter, a length of string, an S-hook. For the class, you will need to get from the kit the overhead of the Egyptian pyramid and extra rubber bands. Teacher-provided items would include a dual-scale ruler, a pair of scissors, and a stack of books that measures 4 inches from the table. You'll also need to make activity sheet copies, sheet 9, parts A and B. To get ready for this activity, you should cut 1 meter piece of string for each team of 4. The string should be tied around the bricks if you have removed the string from the other bricks. Tie it like you would a package. To the push-pull meter, you're going to need to add 2 more rubber bands. So there is a total of 3 rubber bands. Be sure that the rubber bands are twisted before you loop them over the brad on the opposite side. The reason you need to have these 3 rubber bands is you're going to be pulling a brick with the push-pull meter. Introduce the lesson by showing the overhead of the Egyptian pyramid and tell the students that the building blocks weighed up to 20 tons. Ask how they think the blocks were transported to the building site without modern-day machinery. Students will probably recall Activity 5 when they learned how the rollers were used to move the blocks. Ask ways the stones were moved to the top of the pyramid. Distribute the activity sheets and the materials to the students. Direct the students to use the push-pull meter to measure the amount of force needed to lift the half brick from the table to the top of the books. Okay, Kathy, why don't you help me do that right now?
Okay.
Okay, first of all, we're going to put this S-hook on the rubber bands.
Okay.
Oh, well, let's do it on the brick first. Okay, great. All right, then attach it to the rubber bands. Okay, now we're going to lift the brick to the level of the books, the stacked books.
Okay, it looks like it says about 7 units of force.
Okay, great. Now we want them to measure the distance from the table to the top of the book, which is 4 inches. They can record this in question 1. Then invite the students to imagine that the brick is an ancient building stone and the stack of books is the top of the pyramid. Ask them for ideas of ways it would be easier to move the stones to the top of the books. Each team receives a short board. Direct the students to place the board against the stack of books to make a ramp. Explain to the students that the ramp is a simple machine called an inclined plane. A plane is a flat surface. Inclined means that something is sloped. Thus, an inclined plane is a sloped surface. Ask students to name places where they have seen inclined planes being used. Place the brick at the end of the ramp. Hold the board to keep it from shifting. Drag the brick up the ramp using the push-pull meter. Kathy, let you and I do this together.
Okay.
Okay, we've got the brick.
I'll hook the S hook onto the string.
Okay, let's do that first.
Thank you. And then I'm going to hook that up to the push-pull meter and try to keep it in the center.
Okay.
You hold the ramp steady, and I'll pull. And if you could read that for me.
Okay, it's 3.5 units of force are used to pull the brick up the ramp. Okay?
Okay, I'll record that. 3.5 units.
Mm-hmm. Now, so then we're going to ask the students to measure the height of the books, which is 4 inches.
I'll record that at the top part. We lifted it 4 inches.
Mm-hmm. Now we're going to ask the students to measure the distance that the brick traveled up the ramp. We're going to use a ruler here, and this says 10.5 inches.
Okay.
One of the things that we need to be sure that teachers do is that if you're going to use a standard measure, inches, then you need to use it consistently. Or if you're going to use metric, measure the height of the books in metric and the length and the distance that the brick was pulled in metric, so which would be centimeters. Looking at the data that we gathered as a result of the investigation, what do you think the students would conclude?
Well, looking at the amount of force that needed to lift the brick from the top of the books, it took half the force to drag it up the ramp. But yet, when we measured the distance, it took a little over 2 times the distance to be able to get it up the ramp.
Wow. Students should conclude that it took less force to drag the brick than to lift it, but the brick had to be moved a greater distance. Point out that Egyptians used both rollers and the inclined plane to help them move the building stones to the top of the pyramid. Ask the students for ideas of how we could decrease the amount of effort used to drag the brick up the board. Kathy, what are some ideas that you think they might come up with?
Well, I think they might say if we had not quite as steep a slope, that maybe that might take less effort.
How could we decrease the slope?
Well, if we maybe have it go out further, a longer board.
A longer board. I just happen to have a longer board. Okay, so we're going to remove that one.
Okay.
Okay, we need to steady the board on the books.
Okay.
And let's start in the same position as we did before. We're going to use the push-pull meter.
Okay. Click it on.
S-hook. Okay.
I'll tell you what.
Got to start at the same place, okay? And I'm going to hold the board,
and I'll pull. And then if you could read.
That is actually about 2.5 units. Okay.
2.5 units. Let me write that down.
Okay.
That looks a lot longer. Do you think we need to measure this and see how far we had to drag it?
I think we should, because we need to be as consistent as we can. Again, consistent with the units of measure. But because we have 4 inches, our books are stacked 4 inches high. Let's use inches right again. Okay, there's 12.
And 8.
20 inches. So let's record that it took 2.5 units to move of force to move the brick 20 inches.
Okay, last time it took on the shorter board, it took 3.5 units of force.
Okay.
So we even have 2.5 units of force on the longer board, so it took even less force to raise it up.
Okay.
But last time we had to drag it 10.5 inches, and this time we had to drag it 20 inches.
So what do you think the students would conclude?
Well, it seems that we're having to drag it a lot further, but it's taking even less effort to have to do that.
Students should conclude that the inclined planes decrease the amount of force it takes to raise an object. However, the trade-off is the distance to raise an object is increased. For cleanup, remove extra rubber bands from the push-pull meters, collect bricks, S-hooks, push-pull meters, pairs of boards, and a roll of string, and return these to the kit. Now it's time to read page 9, Inclined Plane, in the Delta Science Reader.